Hi, and welcome to the Worldwide Center of Math's Problem of the Week. This week we have a Halloween-themed problem, and the problem is, in a rectangular room with dimensions 30 by 12 by 12, a ghost is located in the middle of one of the 12 by 12 walls and 1 foot away from the ceiling. A person enters the room and stands stationary in the doorway of the opposite 12 by 12 wall. Their center is 1 foot up from the floor. What is the shortest distance the ghost can take to scare the person? If the ghost can only can't float but can only glide along the walls, ceilings, and floor. So basically what that means is that the ghost can't take the direct route from here straight to the person across the middle of the room. It can only kind of glide along the walls and floor, so it has to stay along the outer bounds of kind of the picture that we drew. So really what we want to do is sort out what's the fastest way the ghost can take. So obviously some of the more immediate suggestions that probably come to mind are simply trying to stay in the same vertical plane, not moving horizontally at all. So perhaps going straight up 1 foot, crossing along the ceiling, and coming straight down to scare the person, which comes out to be 1 foot here, plus 30, plus 11 down to scare the person whose position is 1 foot up from the floor. So that's comes out to be 42 feet. Another obvious solution would be for the ghost to take kind of the opposite route, which is to go all the way down the sidewall, cross the floor, and up 1 foot to scare the person, which is the same solution, just switched. And what you'll find is that with any other solution that you can come up with, where the ghost perhaps moves horizontally across the plane, so the ghost moves to this side, down, and across, or moves basically any horizontal way, it'll take more than 42 feet. This is actually the shortest distance with the ghost staying in simply the vertical plane, since these two are on the same plane vertically, just on opposite walls. But what we can do actually to show what the shortest distance is, since we know that a straight line is always the shortest distance between 2 points, if we flatten the whole grid of the walls in the rectangular room, we can find a shorter distance that the ghost can travel across the wall. So drawing out what it would look like if we flattened the entire room, obviously sidewall, floor, sidewall, ceiling, and the end walls coming off of the floor and the ceiling respectively, with the person and the ghost being 1 foot away from each. The ghost 1 foot away from the ceiling and the person 1 foot away from the floor. What we can see is that we can actually draw a straight line from where the person stands here or from where the ghost stands, straight down across as a diagonal, down across the ceiling, the sidewall, and the floor, and it'll end up being the shortest distance. So let me just do that. So obviously we know that a straight line will be the shortest distance between 2 points, but we really don't have a distinct way to find out what that length is. What we can do though is make a triangle and use the Pythagorean theorem. So creating a triangle from this diagonal, what we can see is the length here is, since we know that these walls are 12, it's 6 plus 12 plus another 6 ends up being 24. And that this length here is the 30 from the length of the floor, plus 1 on each end for the 1 foot that each respective person and ghost is away from the floor and the ceiling. So the length here is 32, and what we can do is just take 24 squared plus 32 squared and figure out what the length of the hypotenuse x is. So doing some algebra, what we can see is that 24 squared, 576, plus 32 squared, 1024 is equal to x squared, which ends up coming out to 1,600 is equal to x squared, and x therefore is 40. And that obviously, as we know, straight line is the shortest point between two different points, is the shortest distance that the ghost can take to scare the person, and kind of drawing what that would look like in the three-dimensional version of the room. It would look something a little bit like this. So basically the ghost would obviously cross the 1 foot distance from the end wall, move onto the ceiling, then onto the side wall, down onto the floor for a little bit, and then cross into where the person would be standing, and they would be able to scare them from there. So that's all we have for you today for this week's Problem of the Week. I hope you enjoyed watching it. Please check out some more of our videos on YouTube, check us out on Facebook, and follow us on Twitter. Thank you.